Good morning.
Good morning, ma'am.
आपण एक 2-5 मिनिटं थांबूयात कारण कोणीच आलेलं नाही
हो. थांबूया,
बाहेरून.
थांबूया, थांबूया. काय इश्यू नाही. थांबूया आपण.
Hello. Can you hear me?
Yes, madam. Yes, madam.
Yes, thank you. So you have all downloaded the books? You have all downloaded the books, book number 1, 2, 3, 4?
Uh, yes, madam. I have the books, madam. It's there.
Yes. We downloaded it.
This is all.
Actually, these are 10 years old books now. They are yet to revise. Probably in next batch they will revise the books. So we'll start.
Yes,
Good
madam.
morning. Myself,
Good morning.
Dr. Smita Marathi. I'm basically a mechanical engineer and done my master's in energy technology from Pune University and PhD in mechanical and materials technology from Pune University. I'm a certified energy auditor of 2006 batch. So it was third batch of masters also and third batch for this energy auditors exam. So that time we had Gande sir as a faculty in our master's course, and he insisted all the students, please go for this exam. This is something new that has come. That time, what the future of energy auditors or managers was absolutely not clear, and also yes, in initial years there were no takers, I would say, or it was not mandatory for designated consumers to have energy managers. But later on, slowly, the implementation that has happened, and now with CCTS, that is a carbon credit trading scheme, that will come in force in India from 2026. It will be mandatory that the verification will be done by accredited energy auditor with GHG background and certified energy auditors with GHG background. So it will be important if you are working in GHG or carbon market. It will be really important if you have both GHG verification qualification as well as the energy auditors qualification. So as you all know that there are four books, we will be initially how we have planned this courses. Initially we will have all the initial chapters and book number one that will be covered. Book number one is almost all is kind of descriptive one. Okay, here I would suggest prepare for your MCQs really well, because MCQs will be there for 50 marks, and if you score maximum out of maximum in MCQ, then your job becomes easier to concentrate on your short answer questions and long answer questions. So how you should prepare on NPC or BE's website, you will find the question papers and answer sheets. Also, you will find chapter-wise MCQs. If time allows today, I will show you where to search it for. But if you will prepare well for MCQs, 50 marks, at least 48, 40 to 48 marks will be sure in the first section, and it will be easier for you to qualify that paper. So paper one, not that tough, but yes, you have to remember the statistics and the definitions which are there. So I will be starting with chapter one, energy scenario, and I would request now I know the time is very scarce, but during the whole week please go through whatever we have discussed during the classes and whatever we are going to discuss in next week. Be in a sense for any faculty that will be told to. More you will practice or more you will open your books, it will not come as a surprise when you are preparing for your exam. For your last paper, that is paper number 4, all books are allowed. But I would say, except formulas, don't keep your dependency on the books, because you have only 2 hours and you have to complete 100 marks paper. We'll straight away go to chapter number 1. So what we are going to see is types of energy sources, life of energy sources, energy scenario in India, energy versus economic growth, energy policies, pricing and reforms. See, these are very generic terms, and more or less by now with your experience, you already are aware of many of these things. That what are different types of energy sources. Then what is the life? Then energy scenario in India may be something different if you've not come across so far. Need of energy conservation, we all know. Energy security and strategies for future, we will discuss. However, in last 10 years, this area has changed a lot. For this exam, we will just consider 2015 data, which is part of this book. I generally prefer to open the book because sometimes I have experienced that participants they have not opened the books or they are not very well versed with book. So I have not prepared any PPTs. We will follow the books. So what do you understand from commercial and non-commercial, primary, secondary,
Some
energy?
disturbance is coming, madam. Disturbance is there, madam.
Disturbance is there. Okay. Now it's okay. Now my voice is clear.
Your voice is, but some background sounds are coming, etc. Somebody maybe.
Background sounds, yes, actually. Yes, that cannot be avoided.
No, we
Sorry.
can ask for
In my next class,
participant
I
to.
can avoid the background voice. So at this moment, I cannot change my place.
Not yours, madam. Something is coming. Some
I
apartment.
know that there is something behind going on around
Yeah.
me. I'm extremely sorry for that disturbance.
Okay. Okay.
Okay, so please, what do you understand from primary energy, secondary energy, commercial, non-commercial, renewable, non-renewable? We'll quickly just talk about this. Anyone? Okay, let's not.
Coal, whatever
Yeah.
we extract from nature is primary energy, maybe coal.
Okay.
It will, and secondary
Yes.
is
So
electricity is secondary.
electricity secondary. Yes, absolutely. So whatever we get it from nature, it is primary energy. So it will also include wind, solar, geothermal, fossil fuel, and nuclear. So all these things are primary energy. We get it from the nature. And secondary energy is when we process the primary sources and convert it into the higher form. Steam, compressed air, or electricity will be a secondary energy. Then commercial and non-commercial. Commercial energy, as the name says, it will be available in market for certain price to be traded. So that will be called as commercial energy. And non-commercial, and the example will be petrol, diesel, electricity, coal, whatever you can trade in market for in exchange of money. And non-commercial energy is something which is not available for trade, or we do not pay for it, like animal energy. So people use in agricultural animal energy, they use animal or the human energy sometimes, porters. Then we use cow dung and make gauri, we call in Marathi. So that is also not commercially, or it's not that largely traded in the market. So that is non-commercial energy. Or wood that is being used in rural areas, so that is also not commercially traded. So that is non-commercial energy. Renewable, non-renewable, you already know. Renewable energy is something which is there and it can be renewed, so it can be replenished. But something which is exhaustible, which cannot be replenished, is non-renewable. That is all the fossil fuel sources. Okay, this definition is very important. Please do remember, like we in global market, generally everything is converted into equivalent to US dollars. Now few countries have started their own currency as well, insisting on their own currency, but generally it is equivalent to US dollar because they were dominating. Same way here in energy, wherever we use tons of oil equivalent, TOE. So 1 ton of oil equivalent will be 1 into 10 raised to 7 kilocalories. Okay, what is the gross calorific value of oil?
10,000, 10,000 kilocalories.
10,000. Yeah, yeah, yeah. Thank you. So 10,000 kilocalorie, and 1 ton is 1,000 kg. So 10,000 multiplied by 1,000 gives you 1 into 10 raised to 7. That is how we have arrived to this number, 1 into 10 raised to 7 kilocalories. So generally you will find in MCQs, they will ask you straight away 1 tons of oil equivalent. So in kilocalories it will be 1 into 10 raised to 7. Kilowatt hour 11,630, and if we convert it into megajoule, it will be 41,868. Okay, so this is very important. Either they will ask you direct, or they will ask there are 2 tons of oil equivalent or 2 TOE, and what will be the conversion. So you have to choose from the answers. Okay, then they've given the definitions. Primary energy sources, we'll just see the figure. Okay, I'll just expand it a bit. Now it is properly visible. No, it's better, I guess. You can see my screen now. Sorry. Hello.
Madam. Yes, madam. Yes, madam.
Yeah, yeah. Okay, okay. Yes. So, see, gas well, gas, coal mine, coal from coal mines, then crude oil from wells, uranium mines. So this thing has to be extracted, and whatever we get from nature, so extraction, and then some treatment has to be done. Then further with that treatment, we go to the secondary energy. So primary energy is this, and secondary energy is steam power. Okay. Commercial and non-commercial. So commercial, we have already seen that energy that is available in the market for a definite price is known as commercial energy, and the examples are electricity, lignite, coal, oil, natural gas. So in short answer questions, you may find that what is the difference between primary, secondary, or commercial, non-commercial, renewable, non-renewable. It may come for 5 marks. Non-commercial energy, any kind of energy which is sourced within a community and its surrounding area, and which is not normally traded in commercial market, is termed as non-commercial energy. Here are the examples: firewood, agro waste, rural areas, solar energy for water heating, electricity generation for drying grains, fish and fruits, animal power for transport, threshing, lifting water for irrigation, crushing sugar cane, wind energy for lifting water, and electricity generation are non commercial energy sources. Renewable, non renewable, you already know. Here are the types of examples of renewable and non renewable. So it forms solar, wind, biomass, geothermal, hydro, and non renewable is obviously those are fossil fuels and nuclear. Okay, now we come to global primary energy reserves and commercial energy production. See reserves. What is the difference between reserves, production, and storage? Anyone? Reserve, production, and storage. What do you understand by this? You can hear me?
Yes, yes, you are
Anyone?
audible. Reserves
Say
may be
reserves.
coal, uh, uh, the stock we have in the mines, those can be extracted. Reserves.
Yes. Reserve. You are absolutely right. Reserves are uh, the mines where these resources can be extracted, and storage will be the place where the extracted resources are stored. Okay, and production is, whatever is daily production required. So there is one term, very important term, that is R by P ratio, reserve to production ratio. And what will it give us, for how long that resource will last? Okay, so if we have reserves of 1,000 ton and production is 10 ton, what will be R by P ratio? Reserve is 1,000 ton, R by P is 10 tons. What will be R by P ratio?
100.
100, absolutely. So you are, if it is annual, if these are annual figures, then it will last for next 100 years. Exactly what it mentions here. See this. There is enough coal to last around 113 years at current rates of production. Okay, so we all know that how coal, oil, and natural gas, that these fossil fuels have been formed in ancient era, when these plants and animals, they got buried under the earth, and then with heat and pressure over the years, they it formed crude oil and also coal. So coal is most abundant resource that is available all over the world, and there are different types of coals: peat, brown coal, that is lignite, subbituminous, bituminous, and anthracite. So anthracite is the coal which is having highest percentage of carbon in it. All the matters are made up of hydrocarbon chains that we all know, hydrogen and carbon. More the carbon content, it will give more calorific value, because C forms, carbon is burnt, it forms carbon dioxide. When hydrogen is burnt, it will form hydrogen dioxide, that is H2O, that is water. But that water, it absorbs heat to get evaporated, right? So that heat is not being utilized. Rather, the heat is going away with water vapors. Second comes bituminous. So carbon percentage is lesser than the anthracite. Then subbituminous, then goes to lignite, then peat. So the lowest carbon percentage you will find it in peat, but we find coal in all these forms. Okay, Indian coal is having high sulfur and high ash content, whereas the coal from other countries. I'm sorry for the disturbance. I'll just see if I can, change my location. I can change my location. Give me 2 minutes. Just 2 minutes. Am I audible now?
Madam, audible.
And okay, so we were talking about R by P ratio. Here, see, as production increases, and if we don't find new wells, what do you think? R by P ratio will increase, decrease, or it will remain constant?
Decrease.
Decreases.
It decreases. Right. So these are figures from 2015, that there is enough coal to last around 113 years. Ho- However, even if you will find BP statistical review for 2024, it is still around more than 113 years. Okay. So these are estimates with the technology that was available in 2020, 2014. But now we have improved our technologies, how to measure the area where we can produce the coal or any other reserves resources. So this figure has definitely not changed much. However, the figures for natural gas and oil has changed. this thing I was talking about, peat, lignite, and coal, time and pressure. So this, I guess, you all understand and you all know this, right? Or do we again discuss on this?
No, not required, madam.
Not required. So see, where there was higher pressure and higher heat, there it formed coal. So this is how they have shown here. So more the heat and more pressure and more time has passed, there we find coal. Then we are finding this lignite, then bituminous, subbituminous, bituminous, and peat. And the carbon percentage decreases as you go towards peat from coal. Okay, the important term here. So this is also part of MCQ most of the time. Reserve to production ratio, R by P. If the reserves remaining at the end of year are divided by the production in that year, the result is that the length of time that the remaining reserves would last if production were to continue at that level. Is this clear? So this is MCQ question. And if you'll browse the earlier last few years question papers, more or the less you'll find that whatever highlighted terms in this book are asked in MCQs. What they will do maximum is they will give some numbers in R and some numbers in P and ask you for the R by P. So coal reserves are there in all 75, more than 75 countries available, and the largest reserves are available in USA, followed by Russia, China, and Australia, India. This is reserves. So we will also see something in production, and also we will see something in what I would say in consumption. Okay. So here maximum reserves. See, from these country names, you will find that why these countries are dominating the world economics, because they have already got their energy security. US is having oil reserves that will last next 300 years. Okay, so MCQ they might also ask that which is the topmost country which is having highest coal reserves. So right now I'm also involved in teaching this fossil fuel subject uh, to other students. So there we are referring to BP statistical values of 2024. Also the India's energy scenario. We get the statistics of India also. So there these numbers are completely changed. Okay. Still, all over world, the electricity which is coming from different fuel, we are using 80% as a coal as a fuel. Despite its poor environmental credentials, coal remains a crucial contributor to energy supply because it is abundantly available. And the rate at which it is available is way cheaper than the rate of crude oil or natural gas or any other renewable energy. So coal is abundantly is dominating. Coal will dominate even in 2030, 2035 till 2050. Coal will remain there. So it's not that coal is going to get phased out. Now we come to producer. So earlier what we saw, reserves. Not necessary you have reserves, you're producing that much. See, here US is not producing higher, but China is producing higher. We will just see these figures. China is third country having coal reserves, and while it comes to, wait, we will also see these numbers. R by P ratio. Just see the R by P ratios. For US, it is 266. And if we compare the their population, you will realize that this reserves or how much energy security these countries they do have. US it will last for 266, Russia it is 452, China just 31. And as against that, India it will be 100. So the average, world's average, this is world's average is 113 years. Here just see the top coal producers. China. China is producing 4 times US. So their reserves will, so what will happen to their R by P ratio? US and China.
China will get reduced, madam, R by P.
It will get reduced, but it will get reduced faster than US. So US coal will remain for longer than China. Then we come to oil. So oil, when we are talking about trading oil, they use unit of billion tons, or sometimes they also use the unit barrel. Okay, when we go globally, they use unit barrel. So what is one barrel equivalent to? Equivalent to
160
what?
liter. 160.
160 liter. Yes. So one barrel is equal to, almost is equal to 160 liters. So these are proven world reserves. Again, we are talking about reserves, not the production. So reserves, proven reserves, we can see Venezuela, followed by Saudi, Canada, Iran, Iraq, India. Just look at India's reserves. Just 5.7 billion barrels. And that forms 0.3 percentage of the total. How long it will last? 17.5 years. And how many years has been passed in between? Like we are talking about the figures of 2014, and now we are discussing this in 2025. So what do you think?
7 years have passed.
4 point, yes, 10 years, almost 10 years has passed. So it will last another
7.5.
7 years, only 7.5 years. And this is really alarming. It is very alarming that our own reserves will not last longer. Here there is no name of China in top 5. So Saudi Arabia was the largest oil producer. So look at the production, oil production. Saudi, the largest production, followed by Russia, US, China, Canada, Iran, followed by others. Okay. These are very interesting numbers. If you're following global energy market and what is happening around there, who is having alliance with which country, and how many, how this is politically driven.
What about US, madam? US is not given.
US is there,
No,
446.
Number 3.
no, world oil reserves may. US is there.
Pardon? Here it is then. Reserves. Reserve it's not there. Okay, reserve is not mentioned. But
Yeah.
there was a news few years back that US is purchasing oil from other countries and filling their reserves. Okay, so they are having some storages and they are filling those storages. They are storing this oil as well to have more energy security. So when you will hear maybe Joe Biden or Trump, they are trying to go for energy security and ensuring the energy security for longer, more than maybe 100 years. See what it says. If production continues at today's rate, many of the major producers such as US, Russia, China will have their oil fields largely depleted within a decade. At that point of time, world may have to depend mostly on Middle East for oil. So we have already completed one decade. Still, it's not that dire situation at this moment. Middle East, the R by P ratio, everywhere you will see reserve to production. It is a average of about 78 years and is much higher than that of non-Middle East countries. How this crude oil has got formed? So as on Earth, on land, the plants and animals got buried. Even something that has happened under the ocean. Tiny sea plants and animals that died and were buried on the ocean floor over the time they were covered by the layers of silt and sand. And that is how this oil and gas deposit they have been formed, and now we find it there. So what is oil shale? Oil sand, natural bitumen, and extra heavy oil. We'll just see this. Generally, oil shale that refers to the sedimentary rock that contains solid bituminous materials called kerogene. Just remember these terms. It also might come in MCQs. So kerogens that are released as petroleum-like liquids when the rock is heated in the chemical process called pyrolysis. Pyrolysis is combustion in absence of air, or if the combustion is deprived of air, so it's partial combustion. Oil sands, also known as tar sands, are the combination of clay, sand, water, and bitumen. Okay, natural bitumen is the portion of petroleum that exists in solid phase in natural deposits, and it contains sulfur, metal, and non-hydrocarbons. Extra heavy oil is the portion of heavy oil having an API gravity of less than 10 degrees. Okay. So whatever LNG, PNG, CNG, LPG we get, is it natural gas?
We can say it is a natural gas.
We can say it is a natural gas, yes. So only it is liquefied, it is in the form of compressed, or it is coming through pipe. So that is PNG, pipe natural gas. Then LNG is liquefied natural gas, CNG is compressed natural gas, and LPG is liquefied petroleum gas. In LPG the content might differ, the methane and other content might differ. So natural gas is the gaseous fuel consisting primarily of methane, but it also includes ethane, propane, butane, pentane, and the composition of this natural gas, the gas what we get it from nature, I would say, from wherever the under under the earth or sea. So that is called as natural gas. Before natural gas,
Might be. Hello. Hello.
I think there is some issue at network.
Yes, yes, yes. Okay, okay.
Let us wait.
Yeah.
Hello, am I audible?
Yes, madam. Audible, madam.
Okay, it got interrupted, I
Yes,
guess.
sir. Continue. Let's continue, madam.
Okay, let me. So my screen is visible.
Screen is not visible, madam.
Screen is not visible. I'm not able to share. I'm not able to see that screen sharing option. 1 minute.
Mm.
Okay, can I request if somebody has downloaded this book, open the chapter 1?
Yeah, we can see now, madam.
Now we can see, madam. Now we can see the
Yeah, yeah.
screen.
Hello?
Yes, madam. We can see now. We are able to see your
Yes,
screen.
yes,
And
yes. Sorry. There is some internet interruption here.
yeah, yeah.
Okay, just scroll down. So now you see that repeatedly we are seeing few names: Iran, Russia many times, US many times. So these are the countries which are really dominating the market, energy market. Just scroll down. See, I will not read line by line. That I would expect you to please go through once we complete. So today evening, what you can do today evening or within this week, you will read whatever chapters we have covered, and you will also read corresponding MCQs or corresponding portion what is appearing in the exam papers. So you will be very well prepared for those chapters. Okay. See the carbon dioxide emission with reference to coal. As far as oil and gas are concerned, gas is the purest one because carbon, it doesn't have any pollutants like ash or sulfur. So there won't be any sulfur dioxide or NOx getting formed when gas is burnt. Oil also is natural. um it's one of the clean resource, I would say. Then the coal. Okay. So here, just wait. Global primary energy consumption by energy source. Globally, what do you think is used the most? So these are energy sources. They have not mentioned what it is used for. Okay. What I mean, can anybody tell me what does that mean?
It's a primary sources that after that we can convert it into the either steam or mostly in electricity.
Yes, mostly in electricity, but here they've shown that oil is being used.
Oil is the most.
Oil is maximum consumed.
Automobile sector.
Yes, yes, yes. That is what I was trying to hint. So these are primary sources which are being used. Not necessary those primary sources are used only for electricity, but it can also be used in transport or for heating purpose. So these are all primary energy sources which are getting consumed. So out of which maximum is oil. When it comes to electricity or power plants, then maximum consumption is from the coal. So the resource which is getting used maximum is coal. Not now, but if you're really keen and interested, na, you can follow this World Energy Statistics, BP Statistical Review. I have I have downloaded with me, so I will put it in the drive. Somebody, if though you are interested, you can in future also you can refer to those numbers. Okay, now we come to consumption. So here this is showing primary energy consumption at the end of 2013. You see, China, even in case of coal, even in case of oil, even in case of natural gas, everywhere you will find that China is the country which is having highest consumption of all the primary energy sources, and that is hinting towards something, that they are, you know, they have increased their production. They are in a faster way moving towards being a developed country. When it comes to India, the share is just 4.7%, and we are the most populous country. Being the most populous country, our primary source energy consumption is just 4.7% of the global, whereas China, it is 22.4%. It's almost 5 times higher than India. Okay, so far clear?
Yes, madam.
See, even you can see US 17.8, and if you'll compare everything to the population, so energy consumption per person will be higher for which country? China, US,
US.
and
US.
China, US, and India. It will be higher for
US.
US,
US,
followed
US,
by
followed
followed
by
by
China,
China.
followed by China, and
Russia.
Then Russia.
then Russia and other. Like if we are just comparing three of them, US, China, and India, then it will be definitely first is US, then China, and then India. So in coming, you know, in coming paragraphs, we will also see that energy intensity or energy consumption per person also defines the nature of that country, what state of that country. Higher the energy consumption per person, we can say that they are moving towards developed nation, or they are a developed country. Their lifestyle. Okay. Then we come to final energy consumption. Primary energy consumption is the primary resources you are consuming, and final energy consumption, it will form, it will also add the renewable energy, or you have your own resources, primary resources. You borrow primary resources from other countries. Also, you borrow secondary energy resources from other countries. So what we borrow, we in a sense other any countries will purchase electricity from the neighboring countries. So putting all together, primary and secondary will be forming your final energy consumption. So here also they've used million tons of oil equivalent. So final energy is the form of energy available to the end user following conversion from primary energy. Okay, here. So these are total different types of energy resources when we are counting the final energy. So oil, natural gas, coal, nuclear, hydropower, renewable energy. See, hydropower and renewable energy, they are not combined together. Any reason? Any reason? Do you think?
Maybe it is from different resources.
No, hydro. See, hydro is counted in renewable energy, right? Earlier we have seen hydro power plant. We have said that this is a type of renewable energy. Any
What the
guess?
question, madam?
I have asked. You can see here. See, oil, natural gas, coal, nuclear energy. They are fossil fuel based. Okay, and they're distinct from each other. But renewable energy, when we are saying, we have put it a combined figure. So it will form maybe wind, tidal, or solar, geothermal, everything. But hydro is kept aside. What do you think may be the reason?
Renewable energy is primary energy, madam. That one.
Hi-
Non.
Solar energy is also primary energy. Wind energy also primary energy. And then the electricity. So here we are not talking about electricity or something. It's final energy consumption. See, actually,
Major contributor in
no,
renewable energy.
hydro energy power plants of the capacity more than 25 megawatt are not treated as renewable energy. Okay, matlab not, they are mentioned separately. So they are not counted in renewable energy, this thing, because the environmental impact that is there because of massive structures that are getting erected is there. So they are kept separate. So not necessary that renewable energy will count hydro power plant of lower capacity, but large hydro. This meeting is being recorded. Okay, now my laptop's internet has come back. Okay, so large hydropower plants that will have this issue, environmental impact. So it you will find that renewable energy is also mentioned and the large hydro is also mentioned. So it will be mentioned separately. Do you know which countries India is? Okay, do you know that India is purchasing electricity from other countries? We import electricity.
No, madam, we are not importing it.
We do import, sir.
Nepal.
We are importing from Bhutan, Nepal.
Yeah.
We do export and we also import. So we import the energy based on hydro. Bhutan is having electricity based on hydro power plants. So we do purchase electricity. And that is why I said this energy statistics, India energy statistics or world energy statistics, these are very interesting sometimes. When we are really keen to know what is happening in energy sector or electricity sector, these figures will really help and we will also come to know that what is happening in this sector. You all are already working in different sectors, but now we are focusing mainly on energy and how this energy mix or what is happening globally, what is happening in India. So I would suggest, if time allows, please do read those statistics. Okay, coal sector. Now we come to India. Indian energy scenario. Earlier we have seen the world energy scenario. Now we come to India's energy scenario. So in India's energy scenario, coal, as we have already seen, it is dominating one. Okay, it will last about 100 years with current reserve to production. So in between all, we have found some reserves. So right now, if we talk about BP's India's energy statistics, it is still showing that it will last more than 100 years, though we have completed 10 years in between. So R by P ratio for India is around 100. Coal reserves are mainly confined in eastern and southern parts of country, Jharkhand, Odisha. So the mines and mining, you will find it in those eastern regions. Okay, scroll down. So lignite was at what state? First we saw peat, then lignite, then bituminous, and then anthracite. So the coal which is majorly used for electricity generation in power plant is anthracite, having higher carbon content. So that will be mainly anthracite, followed by all these bituminous, subbituminous, and lignite. So in that, you've seen in that grading, it was last but one. If we grade it in 5, peat, then lignite, then bituminous, subbituminous, subbituminous, bituminous, and anthracite. So we find lignite, and that is the major reason. Though we have abundant coal available, we also import coal from outside. Which country we import coal from?
Australia.
Indonesia.
Australia, Indonesia, both the countries we do import coal from. And there are two reasons. One is obviously the calorific value and carbon content, lower ash content. And secondly, the production cost is lesser in those countries, and import is cheaper than the production within the country. Why it is so? Because there are two types of mining. One is open cast mining and one is deep underground mine or deep mining. Okay, so here it is mentioned over 80% majority of the coal. Wait, the majority of the coal which is mined, that is open cast mining. If some of you might have visited the mine site or seen it in some movies, you will realize that there are two types of mining, that is deep or underground mining. For underground mining, it is energy consuming, and the deeper you go, it will consume higher energy to extract that coal than the open cast mining. Okay, here this is the table which indicates that what types of different coals. What is coking coal and what is non-coking coal? Where is coking coal used?
Might be it is related that you can to make its a length, width, height like structure, or you can give a shape to the pole likewise that.
No. Coking coal is not something
Madam,
related to shaping. Yes.
coking coal is used in the blast furnaces
Yes, yes,
after
yes.
heating the coal.
Yes. So coal is further processed and formed coking coal. So it takes part in the process. So it is used in blast furnaces where the steel is made. So in steel manufacturing, coking coal is used. Okay. So that is the requirement of coking coal. So here the percentage of coking coal, non-coking coal, and lignite is given. In rest of the places, coal is mainly used for heating, and then steam, if it is used only for heating, then it's okay. If it is used in power plant, then it will be used mainly for electricity generation. I hope you all know how this power plant works. Even though you may not, or you may not remember, you will have it in book number 2, the power plants, different boilers, furnaces, heat exchangers, and other things. Okay. So what do you mean by calorific value? What do you mean by calorific value? Anyone? What is calorific
Energy
value
released by
Calorific.
again?
burning.
Yes,
Energy
sir, please.
released by burning. Yeah, no, go ahead, please.
No, I'm not able to get any answer.
Calorific value is the energy, madam, energy, kilocalories. The energy per
Energy.
kg. Energy
Energy
contained in
content
that coal.
in that
Coal.
particular mass or weight, right?
Yes.
Per unit weight.
Yes.
So that is a heating value. Yes. So calorific values are of two types. One is gross calorific value. One is net calorific value. What do you mean by these two terms? Any idea? The GCV and NCV. Please, we all know this.
No, gross calorific value contains all these, impurities, etc. After removing those impurities, it's called the net calorific value. Or impurities or whatever.
Gross
Mm,
calorific value contains this moisture also, which takes
yes.
its energy while burning, and the net calorific value is all deducting the moisture percentage and all this.
Exactly. So see, GCV, NCV terms will be required for you when you are doing the calculations, when you will be doing energy audit. So you all please be sure and please understand. Whenever any matter is burnt, the heating value after burning, whatever we get, the energy out of that burning will be whole in a gross, like gross salary. So company has given us some gross salary, but then what they deduct? They deduct PF, they deduct superannuation, they deduct gratuity, or they deduct some profession tax. So mainly these are the reductions. So what finally you get is net salary. Exact same. Any fuel is having hydrocarbons, chain of hydrocarbons. Here, when it is burnt, the complete energy what we are getting is gross. It will also so carbon getting converted to carbon dioxide, hydrogen to hydrous oxide. That is H2O. Everything together will be your gross calorific value. But H2O, H2O at the temperature of 500, 600 or 1000, where the combustion happens. So combustion temperature will be generally of that range. Whole, it depends on the type of boiler or type of the combustor it is, but the temperature there will be minimum 500 to 1000, 1200. At that temperature, water will not remain in water form. It will get converted into steam or water vapor. When it is getting converted, it will utilize the latent heat, right? For phase change, water requires latent heat to be added. So that latent heat it will take from that heat that is liberated from the combustion, and it will form water vapor. So that ideally that heat is not available for utilization. Okay, so that is the difference between net calorific value and gross calorific value. And again, I will tell you one more relation. When the flue gases, so whatever is burnt, it forms gas. So that gas is called as flue gas. Combustion gas is called flue gas. Those flue gases, they are in power plant. I'm telling, they will go through different utility. What I would say, they will go through superheater bank, then boiler bank, and then they will pass through air preheater. They will pass through air indoor, nay, not indoor, air pollution control equipment APC, and then finally they will be passed through chimney and they will go to the atmosphere. But when they are going to the atmosphere, the temperature of flue gas going out of atmosphere, out of chimney, they have to maintain around 130 to 140 degrees centigrade. Here that moisture will play role. Why we want that to happen? Because below that it will be dew point temperature of sulfur dioxide. So if we are burning coal having sulfur content, it will form SOx. Sulfur, it will form SOx and water vapor in that flue gas, which are being liberated or which were there maybe in the combustion air or which was there in the coal, so moist coal. It will go to chimney, and there if that get condensed, chimney will get corroded and it will collapse one day. Okay, if the chimney is formed of steel or cast iron, it will be corroded. So this moisture plays role there. NCV is different and dew point temperature is different, and why we maintain the flue gas temperature, that is different. But yes, this water forms major role. It will play major role at the end of exit at the chimney. So there is a difference between these two, NCV and GCV. Please do remember this, NCV and GCV. So here what they have mentioned is calorific value, when generally it is mentioned GCV only. High ash content. So Indian coal is having 30 to 45. So 30 to 45% of the 1 kg of coal, if it is 300 to 400 gram is ash, only the rest of the coal will be useful. So it will have a useful content. So depending on the ash content, carbon content and other impurities, our coal is having calorific value of 3000 to 4500. Scroll down. Our power plants consume more than 75% of coal. The effect on environment, we can see it in other chapters also. As the coal which is produced in India is not sufficient and also not pure or having impurities, we do import coal from out of the country. That is Australia, Indonesia, South Africa. Okay. And main exporter of coal to India is Indonesia, followed by Australia and South Africa. Indonesia being, closer than the other countries. And also they have higher production than that of other countries. So here they see India would like to be a developed nation by what? Which year?
2047.
47.
2047. And so we will consume and our demand for these resources will be higher and higher year on year. Okay. However, though we all know that coal is polluting and all, so they have introduced the coal tax, clean coal tax. So those power plants which are using coal, they will also have to pay additional taxes for utilizing those resources. Scroll down. Okay. So see, here they have mentioned something. However, with India already having committed domestic commitment to reduce carbon intensity by 20 to 25% from 2005 levels by 2020. The strategy of using coal for large-scale rural electrification could hamper its efforts to achieve the carbon intensity reduction targets. Yes, if we want to discuss on this topic, I would say that we have not reduced the use of coal. However, same time we have increased the amount of renewable energy consumption and dependency. So right now, how much renewable energy capacity has been installed? Anyone? We have achieved 50% target.
For
Installed capacity.
renewable energy,
Yes.
yes.
Yes. So we have achieved that target. However, we have, that is not generating that much. It is renewable energy is based on the season and time of the day also it will vary. Now we come to oil sector. We have seen 1 barrel is 160 liters. Okay. Mainly we find oil reserves near Bombay High, Upper Assam, Cambay and Krishna Godavari basin. And oil accounts for about 29% of countries' primary energy consumption. Okay. For the world, what we have seen is 33% oil is used. For India, 29% of oil is used. Also, that oil may be getting used both for electricity generation or heating as well as transport. Here, R by P ratio of oil in India is 17.5 years. Currently, India is fourth largest oil consuming country in the world and imports more than 75% of its crude oil. The number must be higher because last 2 years we are getting oil from Russia. We are refining it, and India is also one of the topmost country who is exporting oil. Though we are not producing oil, but we are the largest country which is exporting oil, thanks to Ukraine and Russia, that we are getting those oil from Russia, which we are refining crude oil and sending the oil products to different countries. Since the introduction of new, so Government of India has introduced various policies, NELP, HELP, and 2, 3 more. So new exploration licensing policies. Earlier, it was majorly done by government entities, PSUs. Now, private players have also started working in these sectors everywhere, in coal, oil, and natural gas exploration, everywhere. Generally, these numbers will not be asked. Okay. These numbers are shared just for the participants to understand the scenario, general scenario of energy, because it will be hard for anyone to remember all these statistics.
Yes, my question was that these numbers will getting changed every year. So
These
whether they will
numbers,
stick with the
no.
number or they will stick with
See,
the concept. Means
no,
first, who is the first in coal generation? Who is that have
first,
heart
second,
rate?
and third largest and all, it will
Yeah.
be from this book only. But they will not ask you these numbers. These statistics will not be asked. Statistics, um, statistics like this much. Like here in 2011 or 5.7 barrels, 800 million tons. So these numbers is next to impossible to remember. But yes, you can remember R by P ratio for India, R by P ratio for world, right? So world and India, it will be asked. Who is the topmost country? Who is the topmost exporter, importer, and all? This is all reference with the this book. Though the figures are old or whatever, we are giving exam with reference to this book only. Mainly they will not ask you such statistics because they also know that this is age old statistics, and it is generally the definitions or small questions where you have to do some calculations, tons of oil equivalent, calorific value, changing the units, equivalent units, everything like that will be asked in the MCQs. Okay. Then the natural gas sector. This is the most preferred fuel and environmental friendly. The largest difference between GCV and NCV, you will find it in natural gas. Okay, because it is having higher hydrogen content. Methane, what is the chemical formula of methane? Is CH4. CH4. And in coal, you will find hydrogen, H. You will not find H2, H4, H3. Okay. So here, when we compare gross calorific value and net calorific value, the highest difference will be there in natural gas case. So generally natural gas calorific value is in the range of 12,000 kilocalories. Okay, scroll down. So how it is compressed or at what pressure it is compressed, it is liquefied is mentioned here. So it is cooled to 161. It's not that easy to use natural gas directly. It has to be cooled to minus 161 where energy is being utilized. Then it is liquefied and then transported. So there are challenges of transporting natural gas. Since liquefaction reduces the volume occupied by natural gas by 600 times. LNG is transported by built ships with cryogenic tanks. Compressed natural gas is made, so LNG now we have formed two. CNG is made by compressing natural gas which is mainly composed of methane to less than 1% of the volume it occupies at the standard atmospheric pressure. It is stored and distributed in hard containers, cylinders, spherical shapes at pressure of 200 to 248 kg per cm square. Now we are talking about hydrogen gas. Hydrogen is also compressed at 200 to 400 kg per cm square. And it is also transported using the cylinders. So it will have type 3, type 4 type cylinders. When we are talking about type 3, type 4, that is the thickness of the cylinder, and the material which is used is graphite. Special material will be used for this hydrogen cylinders as well as this CNG. CNG can be used in traditional petrol internal combustion engine. So we find this hybrid vehicles where generally we in a sense, those who are having this travel vehicles, they will have CNG as well as petrol mix. So it will be biofuel vehicle. India's reserves is around 0.7 times of the world's reserves. And mainly it is found offshore. 66% is offshore and 34% is onshore. And bulk onshore production is at Assam, Gujarat, Andhra Pradesh, such coastal area. R/P ratio is 40. For India, coal R/P ratio is 100, gas it is 40, and oil it is 17.5. The LNG projects are capital intensive projects. So the gases what we get it from natural resources are not directly used. Lots of processes that are happening in between, and then it is ready to use. But where it is produced, it is not consumed. It has to be distributed. So the laying of distribution pipelines or transporting it from one place to other, that is adding to the cost. Yes. So see the text written in green. Scroll down. You can see the text written in green. Please remember this. Okay, we move to the next. Electricity supply, electricity energy supply. So the installed capacity is 2,38,000 megawatt, and out of which 40,195 is from hydroelectric power plant, and rest is from mainly thermal, nuclear, and renewable. So if you will see the statistics of 2025, whole statistics is changed. Okay, percentage has also changed. So this shortage and this peak shortage, there is no shortage now. India is an energy surplus country, right?
Uh, Yet, no.
Is energy surplus country. No?
No. As per my knowledge, there is still, we have achieved the whatsoever we required, but surplus is no. I have not read it. Might be my updation is wrong, but we achieved the 100%, but surplus is not yet.
Okay, when we are exporting energy, then do we have surplus? That is why we export.
It depends on the TOD concept, time of the day concept, because production mostly on the daytime. So that's why might be I'm wrong, but you can update, no issue.
No. You have mixed up 2, 3 things. India is energy surplus. Yes, India is energy surplus. So we don't energy surplus in the sense sometimes we have more energy generated than we are consuming. Okay, that is how in India we can call it surplus. But yes, there are few see time of the day tariff. Daytime we produce surplus energy. Yes, and secondly during night time, see we are mainly dependent on thermal power plant. And thermal power plant, there is a turn down ratio. There is a term called turn down ratio. You will learn it in paper number 2. So turn down ratio is something that thermal power plant cannot be switched off completely and switched on again next day. That is because the initial heat that is required for all the parts, and then to start it to the full capacity and produce the electricity, lots of heat is getting wasted. So unless it is planned maintenance or emergency outage, thermal power plants are not kept off. But solar, wind, hydro, mainly hydro, can be regulated. So we can keep one turbine off, we won't generate any electricity. But in case of thermal, turn down ratio is 25. So at least with 25% power generation, we have to keep the plant running. So even night time, we are generating some excess energy that may be used for pumped hydro, or that can be, that is why the time of the day tariff. So the nighttime tariff is discounted one. And that time the energy can be used by these DCs or industry, commercial buildings, and they will get rebate on the use of energy. That is to encourage people to use energy during night time. The time of the day tariff is different, and energy surplus, these two are different things. Okay, here it is a breakup of, just scroll down. It will be a breakup of installed capacity of energy sources. Mainly, thermal power plant is 70%, and it forms highest coal, then gas, and then oil. Hydro is contributing 16.84, nuclear 2.24, renewable energy 12.34, and total is 100. Okay, so this statistics is valid for this paper. Nuclear, though we have 21 nuclear power plants, but we have restriction on using nuclear power plants because we are not getting the fuel. What fuel we get from India, the reserves what we have it in India, are not the concentrated one and the one we require. The uranium produced in India is 2 to 3 times costlier than Indian ores contain only 1.1% uranium compared to 12 to 13% uranium ores mined abroad. Okay. So when it comes to nuclear, we are still dependent on imports. So we have not increased this capacity of nuclear that fast as we have increased for others. Hydropower plant, see, we have potential, but we have not explored the complete potential for hydropower plants because it has got major environmental impact when we are building massive power plants. Scroll down. But as far as maintaining or control is concerned, hydropower plant has got better control over controlling power generation. If some of you have visited these power plants, have anybody visited hydropower plant?
Yes, madam.
Yes. So you might have some idea of how they control the number of gates opening, and they can shut one of the gate, and they can, for Koina they have 4 turbines, so they can utilize only 3 turbines, 2 turbines, depending on the power requirement. This is the chart which is giving an idea of where the energy is being consumed. So 44% energy is consumed in industry. Next is transport, followed by residential, then other. So see, now looking at this chart, if we want to do energy conservation, knowing the world energy scenario, a global energy scenario, India energy scenario, and the available resources, dependency on imports, if India is to devise a policy to go for energy conservation, where they will work mainly in industry, right? Followed by transport and residential. But residential, we have number of consumers. Industry, if we compare industry, number of consumers will be lesser, but they are consuming higher energy. But if we consider residential, the number of consumers are higher. Each household will be consuming how much? Maximum up to 500 units, minimum up to 100 units. Minimum 50 to 100 or 500 units. But industry, they consume in lakhs of units. So there are a number of policies, number of initiatives that has been taken mainly in industry. That is how the birth of PAT cycle has been there. Perform, achieve, and trade, that you will learn it in coming chapters. Scroll down. See, there you will also have to remember this term, specific energy consumption. So the energy consumption in kilocalories per unit of production is called as specific energy consumption. Is it clear?
Yes.
Maybe kilocalories, maybe joule, gigajoule. Yes, just be there on this table. So the energy that is consumed for producing any end product is specific energy consumption. Here, only seven, I think seven, 1, 2, 3, 4, 5, 6, 7. 7 sector has been mentioned, but now we have more than 13. More than 13, around 13 industries which falls under this, which they have given the global benchmarks. India is consuming 25.5 gigajoule per ton to 34.2, whereas world is using 16.5 to 18.5. Just give some attention to these numbers, and then you will realize that India is consuming higher energy for producing the same production. When we multiply it by tons, actual tons, you will realize that how much extra energy is being consumed in India. So this is the opportunity where energy conservation can happen.
Madam, why we are consuming, madam, more than others?
There are many issues. One is technology. So the technology what we are using, maybe they have advanced technology available in the world. So when we are calling world, it may be one of the country. Okay, maybe US, they're consuming less, or maybe Europe is consuming less in aluminum or some other things. See, India is second largest producer of aluminum. Okay, and US and Europe, they hardly have, whatever facilities they have are very small, but they have advanced technology, so their energy consumption is lower than the energy consumption what is happening in India. So mainly the technology, energy efficient use, and the technology what we use to be, we have to go for better technology and find out the opportunities where we can save the energy, where the energy is going waste. That is how this energy auditor's role comes into picture. First, one has to find out that how much energy is being used. Then we have to do benchmarking. What is benchmarking? Is comparison with somebody, comparison with someone. That is what is done here. This is the benchmark, global benchmark, and here is India's specific energy consumption. Okay, scroll down. Transport sector. So the energy consumption in this sector is growing very rapidly next to China. So China, see, it goes with the population also. The state China is, they are also striving to be a uh, developed country, and we are also working towards that. However, their technology growth, or I would say the pace they are going ahead with their new technologies, and India is going ahead with, is not matching. But yes, you will find always comparison with China. So by 2030, the transport demand, energy demand on road would account for 86%, followed by aviation, 9%. Railway, marine is expected to consume 5% of oil that is getting used for transport sector. Coming to residential, commercial services, agricultural sector, what will include in commercial services is big hotels, malls, then commercial buildings, IT parks, hospitality industries, big hospitals. All these forms a commercial entities or commercial buildings. So that will be termed in commercial buildings. So major consumption there, they don't have any production. So major consumption there is electricity. Okay, so if, and in domestic sector there is LPG, so gas that is used for cooking. If we want to do or increase energy efficiency there, mainly we have to attack on electricity. So electric equipment. That is how you will see that we get star rated appliances. Higher the star rating, lower will be the energy consumption. So you'll find the labels on this is 5-star rated AC, 5-star rated microwaves, refrigerator, then BLDC fans, LED lights. So everywhere, all these energy consuming equipments, government has tried to give subsidies or tried to come up with policies where you will find the energy efficiency improvement is mainly the focus. Okay, scroll down. So this is not a debatable point that growing economy will require energy. We are building infrastructures. Every day you will find that number of kilometers of road is getting added, new bridges are getting built, metros are coming up, new transport sector is also seeing the growth. Everywhere we require energy. So growing economy will require energy. So growth in, if we want to keep GDP, what is GDP?
Gross domestic product.
Yes, but what do you mean by?
It is overall product and services
Mhm.
of the country.
It is the valuation of overall product and services of the country uh, in that year. It includes domestic as well as the export, right? So if that growth is to be kept 8%, this is the estimate given. Primary energy supply will be required to be 3 to 4 times over the current consumption. Increase in electricity installed capacity by 6 to 7 times. And increase in annual coal requirement will be 3 times over the current. So that this is what we are talking about 2031, 32, 5 years from now. As far as electricity is concerned, India has reached level of 917 kilowatt hour per person per year. Okay, per capita energy consumption. And you compare it with China, USA, UK, Canada. What do you understand from this? What do you understand from this?
India is India's per capita energy consumption is less compared to China, US, UK. US is consuming around 13 times.
Yes, so that goes with our lifestyle. So the lifestyle China is having, or the lifestyle US citizen is having, or the opportunity, not opportunity, facilities US person is getting, Canada is getting, and what facilities Indian people are getting. So you can compare. So it goes with that. It is proportion to the lifestyle and facilities in those countries. So the energy consumption per capita energy consumption derives your lifestyle. Getting? We'll just scroll down. See, all these things are, maybe I will say 70% known facts to you. Here, only thing is that everything is concentrated in the form of energy and mentioned in this book. These are not new facts. Some of this information might be coming as new, but we all know this. The lifestyle of people when we go to Dubai or when we go to outside India, we find that the energy consumption that they are having, the type of malls or the type of infrastructure is developed there is very different than that of India. It's not only due to population, but it is also, you know, it is, yes, it is due to population as well as the facility or the innovation, the technology these countries are using, and the energy resources they have. When India, like countries, are dependent on import, it will also increase the loan, okay, that we are taking for importing or purchasing this energy sources from outside. Now we come to integrated energy policy. That time when this book was written, we had power shortage, very much unreliability, and high prices. Even today, we have high prices for the industrial consumer, and India depends on imported oil to the extent of 75%, and that raises energy security concerns. It is a concern. Energy security is a concern because oil will remain only for next 17.5 years. Also, consistency in policies governing each sector, consistency in pricing of different types of energy is lacking. See, when you will change the state, you will find there is a difference between two states when we purchase maybe electricity or we purchase petrol, diesel, natural gas. Rate varies with state in state policies. Also, the political influence is there. To achieve these objectives, Energy Expert Committee has made comprehensive review to make recommendations for integrated energy policy that will be there in the chapter number 2. What is energy intensity on purchasing power parity? See, if we are purchasing 1 unit in India and 1 unit in China, how much we spend and whether the conversion rate of currency it matches. Or if we suppose we are getting 1 unit in 5 rupees in India and we convert it in Chinese currency is yen or Japanese currency is yen. I think Japanese currency is yen. So I will
Japanese
take
currency is
example of
yen.
Japan. So I take 5 rupees, convert it into Japanese currency and would like to purchase electricity. If I get 1 unit of electricity, then we can say that we have purchase parity. Okay, our purchase parity. But if it is not matching, then we can say the electricity is expense. So electricity is expensive in Japan or any other country. So this is to come to power purchasing parity. Here they have explained it well. What is purchase power parity? So here they've given the example of egg. If we purchase egg in rupees 3, whereas it costs 30 yen, equivalent to rupees 15 in Japan. So PPP for the egg between Japan and India is 30 yen to rupees 3 or 10 yen to a rupee. In other words, for every rupee spent on egg in India, 10 yen would have to be spent in Japan to obtain the same quality of egg. Okay, I would suggest that you please read about PPP and then we can discuss it in the next lecture if you don't understand this PPP. Because it will take 1 or 2 readings to understand PPP. Long-term energy scenario for India. So we'll just scroll down. So what is long-term scenario? If any one of us sit and we are asked to think about long-term scenario, we will certainly say that we can't phase out coal. Coal will remain. While we say coal will remain, we will see how we can increase the renewable energy capacity. So till 2030, we are planning to add 50 gigawatt capacity based on coal. So it's not that coal is getting phased out, but we are still adding the capacity, power plant capacity based on coal. So the coal production will be there. Maybe we will increase the coal production. Coal imports are expected to increase drastically in future to satisfy industrial and power generation requirement. By 2047, we are aspiring to be a we are aspiring to be a developed country. For that, we will require higher production, higher industrialization. You will see tremendous infrastructure growth will be there. And for that, we require energy and we will be dependent on higher imports. Oil demand will also increase tremendously. And as we all know, more than 75% is the dependency on oil import. And so our relations with our neighboring countries and this energy, energy reserve, those countries having its own energy reserves. So we are keeping good relations with Russia. We are keeping good relations with Saudi and those countries who are exporting energy sources to India. And energy is mainly dominated by geopolitical issues. Come to natural gas. In keeping with worldwide trend, the demand of natural gas is going to increase. No second thought on increasing its usage. Well, gas pipelines project, yes. Okay, I thought somebody's calling me. Okay, geographically, India is strategically located and is flanked by large gas reserves on both east and west. India is located relatively near to 4 of the top 5 countries in terms of proven gas reserves: Iran, Qatar, Saudi, Abu Dhabi, and a large natural gas market of India is a major attraction to LNG exporting. I think somebody is discussing something.
Kiran.
Just
Mr.
mute
Kiran
them.
Nikam, can you mute yourself, please?
Okay. Fine. Sorry for that interruption. So the large, we are fortunate to we are based where we are getting gas from east and west region, both Iran, Qatar, Saudi, Abu Dhabi, and the large gas market attraction to LNG exporting countries. In order to encourage gas imports, government has kept import of LNG under open general license OGL and permitted 100% foreign direct investment FDIs. Come to electricity. This is not the scenario, huh? Already reeling under peak demand and energy shortage. We hardly have energy shortage now. 100% rural electrification has happened. No, I would say 100% rural electrification has not happened. But yes, we are now self-sufficient as far as electricity is concerned. We do import, we do export too. So we have targets to reduce the T&D losses, then aggregate technical and commercial losses. So you will find earlier we used to call it MSEB in Maharashtra State Energy Electricity Board. Now they have formed 3 different companies. Genco, which will just take care of generation based on the demand given to them. So they will generate and give it to Transco. So Transco will be charged for all the energy that is getting generated. So then it will be transmission lines. They will go to discoms and then they will distribute it to the domestic or commercial or agriculture or industrial sector. So these 3 companies, now these 3 are different entities. Earlier it was a single entity. So electricity pricing in India, how it is done? What do you think? It is majorly, influenced by the political, there is a political influence on our electricity pricing as well. So earlier, even in some states in India, the electricity is being charged on the basis of kWh, that is units, kilowatt hour. But now in Maharashtra, they are charged on the basis of kVA, that is the active, sorry, the total power that is supplied. I will come to that, or I think in your chapter paper 3, you will be reading the electricity bill. There you will find this difference. So there is, if you will find your own electricity bills, you will find few terms. kWh, you won't find this demand won't be there. Connected load will be there. What is your connected or sanctioned load will be there in domestic bills. If you are working in this sector and you've seen the commercial or industrial sector bill, you will find they are charged on the basis of the demand. They are also charged if they don't maintain power factor. They are also charged if the demand increases, and they are also charged on the basis of electricity units that they are consuming. Agricultural sector and domestic sector is heavily subsidized by commercial and industrial sector. So commercial and industrial sector, they already have higher tariff, higher base rate, and on top of that, they also see TOD. TOD is time of the day concept. So when there is a peak demand all over, during maybe morning 9 to afternoon 12, when the office starts, when even domestic load is there, all the industry requires agricultural load is there. At that time, domestic will have the same rate during whole day, night. Domestic sector will see the same rate, same unit rate. But industry has to pay extra. So suppose industry base rate is 7 rupees and domestic base rate is 4 rupees. We, as a domestic sector, we will be charged 4 rupees even if we consume electricity during night, day, up to 100 units. But commercial sector, they are charged by 7, that is base rate. But they will be again charged plus 1 or 1.5 or 1.3, it's mentioned there. So they will be charged extra. So they have to pay 8.3 rupees for consuming 1 unit because it is a peak demand. Then during 12 to 6, there will be flat rate, that is 7 rupees. And by 6, again we will have the load of lighting and domestic load will be increased. So that time in the evening from 6 to maybe 10, again the tariff will change. By 10, the domestic load reduces, there is no agricultural load, so there is no, the demand will reduce. So with reduced demand, we can't shut the thermal power plant. Thermal power plant will be there. So they are encouraging, okay, industry, if you're using this electricity, we will give you in discount. So they will give discount of 1.1 or 1 rupees. So the base rate will be, the final rate will be base rate minus discount, that is 7 minus 1, that is 6 rupees. So if industry is using or commercial sector, they're using electricity during night, they will be paying lesser amount if as compared to the day. So that is availability based tariff. Okay. Sorry, availability based tariff is something different. So availability based tariff is something to do with power exchange. Now we know that there are private players as well as government grid. So grid will be same, but government entities who are generating electricity, as well as you will find Reliance, Adani, or Tata Power, they are generating electricity. So that electricity will be available for consumption. Everybody will have their own rates. Commercial sector and industrial sector, they can purchase power from any of these. So whatever is availability and whatever is that time tariff, or they have to give the demand that industry will say, in another 30 minutes, I will require this much energy. What will be the tariff? So they will find that is trading that happens on the power exchange, and they book ahead the 1 day ahead or even before 30 minutes, they can book this. So it's availability. If the surplus power is available, you will find very discounted rates. If the power is not available, like in sunny days, you have good solar power available. So that time you will find electricity rates are different as compared to the monsoon season. That is availability based tariff. Energy security is very important term. The basic aim of energy security for a nation is to reduce its dependency on the imported energy. For India to go for energy security, it is tough. At this moment, it is tough because 75% import, oil import. Then coal, we are dependent on import. Natural gas, we are dependent on imports. So when we are heavily dependent on imports, it is not easy to go for energy security. That is how we have started our programs. We have our commitments towards reducing carbon emission and commitments for energy security to increase renewable energy. So the continuous, what is energy security, is also asked in MCQ or short notes. The continuous availability of energy in varied forms in sufficient quantities at reasonable price. All these three are important things. Continuous availability in varied forms in sufficient quantities at reasonable price. Okay. So what comes under energy security? I would suggest please read. You can read it later. So what can be done to reduce import? And this is why we require to understand the specific energy consumption in energy intensive sectors. So directly we can arrest those extra energy consumption, reduce the requirement of energy, or that wastage of energy can be utilized somewhere else. So there we have to improve the energy efficiency. We should see that improving fuel efficiency, then adopting energy efficient and demand side management. So there should be a good demand side management. Like I said, availability based tariff, and the second is time of the day tariff. So industries were, encouraged to stagger their operations. If some industries they require heat and ventilation, or there are few factories which are working in like ice factories, ice cream factories, or where the chilling effect is required, so they are encouraged to do these operations during night time. So that is demand side management. If everybody is demanding this energy during daytime, it is difficult to manage it. For that, even the Kusum Yojana, if you've heard of Solar Kusum Yojana, agricultural sector has been subsidized to give the electricity pump along with these panels, solar panels. What has happened due to that? The agricultural load has drastically reduced. So dependency on the grid has reduced. So that is demand side management. So there the demand is managed. So that is something which can be done in demand side managed. That government has done. Promotion of public transport, mass transports. That is how this metro and rail and monorail and public transport is getting, new investment is being done in this sector. India being a first populous country, it is also hard to manage all these projects and complete it in stipulated time period. But yes, government is working in that sector too. Substituting the imported fuel, what we also have come up with ethanol policy, biodiesel, coal to oil technology, biomass to gasification technology. So we are working on different technologies. Then diversifying energy supply sources. We are also working on hydrogen, so clean energy. We are also coming up with improved oil recovery. So if we improve the production or if we improve the technologies, it will obviously reduce the energy dependency. Then stepping up the exploration, equity oil, gas, coal from other countries, setting up energy intensive units abroad. So this is something that we won't use our energy sources in India. What we will do? We will use energy sources in other countries. Okay. New domestic sources like nuclear fast breeder reactor, thorium reactors, gas hydrates, promoting community biogas plants, energy plantations. What is energy conservation and why it is important? Energy conservation and its importance, we really don't need to have two opinions. It is very much required, and we have seen that after industrialization, 1900s and from year 1900, the way fossil fuel or the energy is consumed is tremendously high. Okay, unless we reduce the energy consumption or the dependence on fossil fuel, we are just emitting carbon dioxide, we are emitting GHG gases, which is in a way contributing to global warming, and there are different climate change. Also, for India, the energy conservation is important because of the limited resources what is available and how it is been done, how energy conservation can be done, utilizing the available resources efficient way. Then for domestic sector, you must have seen Bijli Bachat Yojana, or there was distribution of LEDs in discounted rates, CFLs in discounted rates. So government has come up with different policies to increase the dissemination of these energy efficient luminaries for the domestic sector, because the main load is lighting. Main domestic load in the domestic sector is lighting. For industry, they have been termed as designated consumers, and these designated consumers are given the target to reduce specific energy consumption. So you what numbers you have seen in the earlier tables, specific energy consumption for these industries, that has been that is getting revised year on year, and companies are given target for 3 years that you have to reduce it to this level, or else you have to buy the certificates, energy, what is it called, e-certs, energy saving certificates from other industries. E-certs, it will be introduced in coming chapters. Okay, benefits of energy efficiency, this you can read. Reduced energy bills, increase energy competitiveness, increase productivity, increase profits, reduced energy imports, then avoided cost on, so that cost that is reduced on import that can be used for poverty reduction, conservation of available resources, reduce GHG. So see, till the time you become energy auditor or energy manager, we will be completely continuously discussing on energy. But when you will complete this energy audits and all, next year onwards, everybody will be talking about mainly on GHG. So next step to energy reduction or energy consumption will be GHG consumption or GHG removal. Okay. So this is the end of this chapter number 1. Any queries, anything, we can discuss it now or we can discuss it later. But I would suggest please go through the complete chapter today, tomorrow, the early the better. And why we are opening this book is that you get familiar to the book, what is written where, and at least because of this class, you will come to know what are the terms that are mentioned in this. So you can feel free to open your question papers, last few years question papers, just browse through and locate, okay, what types of questions that is being asked in MCQs or in other sections. Fine.
Yes, no.
So we will, you tell me if we want to cover this question answers, we will just cover this.
Objective type, MCQ, madam.
Objectives, yeah, MCQs, this quickly, yeah, because we will take a break and then we have to also start. But we will start at 11:20, okay? Not
Which topic, madam?
11:50.
Next topic is, madam, next topic.
Next topic I need to see. New
Okay.
and renewable energy sources.
Same book 1 only.
Yes, in initial lectures we will complete whole book. Okay, book 1, because this is descriptive, as I said, and it's easy to understand, very easy to understand. So initially we have kept book 1 and chapter 1, 2 of all other books. Okay, so you can start answering. What is the answer of first?
Coal.
Government of India.
Yes, you can attempt
B. Coal.
one by one. Please attempt all these questions.
Clean energy cess. Clean energy, which one is following? Coal. 1 ton of oil coolant.
Yes, what next?
With this, madam, which of the following is not a national mission under PM National Action Plan of Climate Change? This one.
Where are you on? Question
Question
number
3,
2.
madam.
Question
3,
three.
madam.
Which of the following not national mission under Prime Minister National Action Plan on Climate Change?
National Mission on CFC Alternative.
National Mission on CFC Alternatives, right? Okay. Question 4.
Country that accounts for largest energy consumption. China.
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 Coal in our planet is expected to last for 113 years.
Okay.
Major source of electrical power generation in India. Thermal only.
Thermal.
Coal.
Thermal.
Thermal.
Which
No,
of the-
there's coal is not the option.
Thermal. Sorry.
Which of the following with respect to fossil fuels is true? RP ratio is constant once established. It will not varies every year. Which one check? Only changes those. The ratio will changes with both of them.
D.
And there's I think D I think, madam.
D. Changes with
R-
both production and
RP
results.
ratio varies every year with change in both production and results. Nuclear energy development in India is constrained by low percentage of uranium, net percentage of import of uranium. I think this is a D, I think, madam, all the above.
Which
8, madam. Nuclear
nuclear
energy development.
development in India considered by import?
Low,
Yes, all of the above.
all of the above.
Yes. 9.
Availability by ABT is applicable to LCT only.
Madam, seventh question. What is the answer exactly?
It is a
7.
D.
Which of the following list of fossil fuel is true? R by P ratio varies every year with changes in both production and reserves.
Reserve.
Yes. D.
D.
R by P ratio varies every year with changes in both production and reserves.
Okay.
See, if production changes, the R by P ratio will change because the denominator is changing. And if the reserves also changing, the R by P ratio again changes because the numerator is changing. Right? So it will keep varying every year.
Hmm.
Yes. Then
Energy intensity is the ratio of GDP.
energy intensity is the ratio of
Energy consumption per GDP.
energy consumption per GDP. Yes. And you can also just see the short type questions. But I think I will end the meeting here. You can see it individually. We will meet at 11:25, 11:20. Okay.
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 Okay. Yeah. Thank you.
Thank you.